it's more profitable to produce in US and ship it to Europe. But to look at this, from that kind of helicopter view, it's difficult, and you need tools and systems that most of I would say, the chemical companies don't have today. They're starting also to get into the advanced planning optimization, where you do simulations and where you make to order, make to stock, make to forecast analysis, setting the replenishment parameters on different raw materials based on the service levels. This is starting to come into play, but it's still very much, I would say, handiwork. So manual calculations, etc. And I would even say that in most cases, when you ask why do you have reordering point of this product of 20 tons or whatever, there is no calculation behind it. Kind of evolved over time, and it's often driven by the production guys.
So would you know for the smaller organizations what kind of tools and systems they use if they get this helicopter view?
In the smaller organizations, I mean, you can manage it with kind of basic tools like setting up this. I'll take an example. Let's say that you have for your gold customers, you want to have an on time in full of 98%. So if you send 100 orders,
like an Amazon principle, you mean? Or just that it's actually on time, so that they can track it, or that it just gets there on time?
Both. So
okay.
It's the quantity, the quality, and it's also within the time that you have committed to that customer.
Mm-hmm.
So let's say that for a gold customer, you have internally set up an aspiration that out of 100 orders, 98 we want to be able to deliver within 2 days. That means that with that commitment, 2 out of 100, it's okay not to send within 2 days, so to deliver within 2 days. And then the question is, how do you actually set up the value chain to ensure that you can deliver on that target? Well, you need to do then statistic analysis to look at, what is the average lead time, what is the standard deviation from that lead time, so that you can calculate with this statistical value that 98% of the cases can be delivered on time in full. And this you can do then if by crunching data, basically data analysis on the raw material side and also on the finished product side. And in small organizations, you can do that. In bigger environments where you have also, let's say, many different warehouses, you have many different plants, it becomes more complex to do because there are so many more, layers to it. There are simulation tools and so that you can adapt and set it up. I don't have an example where really this is integrated to that level that we discussed earlier.
Okay, and I've understood that this end-to-end process chain, mainly in the environment that we're looking at, don't exist. What would be then the optimal setup given this situation? So is what we're looking at with a centralized procurement and logistics organization working for the different business units, is that optimal? The situation that we're finding is that due to this setup, you have, due to the fact that there's only, compared to the total supply chain, there's only, let's call it a relatively small part that's within the centralized organization. You have them, working for the X amount of BUs with different services, different demands, and it's basically coordinating all these different wishes with very little synergies and central governance. So maybe, I don't know, is it not the organization that you have to look at, but the governance that you have to set up properly, because at least from